Hello everyone, welcome back to my channel Explain Maths. So in this video, I am going to start with a new chapter and the chapter is Introduction to Trigonometry and the chapter number is chapter 8. So in this video, I am going to just give a small introduction of the trigonometry, like why we have to use trigonometry and when we are going to use it. Okay, so let's begin the class. Suppose you have visited Qutub Minar. So this is a Qutub Minar. You went there in a summer break to visit Qutub Minar. Now, if you are looking at the top of the Qutub Minar, you can see a right angle triangle will be formed. Okay, so you are standing over here and when you see the top of the Qutub Minar and from here you can imagine there is a right angle triangle formed. So can you able to find the height of the Qutub Minar without actually measuring it? So if you have to measure this height, it is a very difficult task for you. But without measuring this height, will you be able to find the height of the Qutub Minar? Isn't it? So now it is looking little difficult, right? How to find the height without actually measuring it. So slowly when I will teach this chapter, you'll be able to know that if you have the measure of this angle, which is formed over here, as well as the distance of the base of the Qutub Minar with the place where you are standing. If you know this two part, then easily you can calculate the height of the Qutub Minar. So we will see this slowly in this chapter. Now, whenever you see a right angle triangle, what will come in your mind? First of all, it's a right angle triangle, so one of the angle will be 90°. That is fine. Now, next, is there any theorem which you have studied in your lower classes like grade 7, 8? In a right angle triangle, there is a very important theorem which you use many times while solving the question. Try to recall it. So I guess by this time you must have recalled it, and that is known as your Pythagoras theorem. Okay. So this Pythagoras theorem we are going to use in trigonometry also. Now, first of all, you should understand in a right angle triangle, the side which is opposite to the right angle is known as the hypotenuse of this right angle triangle. And if you remember, hypotenuse is the longest side of a right angle triangle. And the other two sides are the base. You can take one side as base, one as the height of the right angle triangle. Okay. Now Pythagoras theorem, this tells that the square of the hypotenuse, which is AC square, is equal to sum of the square of the remaining two sides, which will give me AB square plus BC square. Isn't it? Many times we have used it when the measure of two sides are given. Suppose AB is given as 4 centimeter and BC is given as 3 centimeter and you have to find the measure of AC. Then in those cases you were using Pythagoras theorem, isn't it? Now suppose you have a right angle triangle, okay, ABC, right angle at B. You know the measure of BC as 3 centimeter. Only measure for one side is given and you have to find the remaining two sides. Then is it possible to use Pythagoras theorem and find the remaining two sides? So answer is no, you cannot find it. But if you know the measure of any one angle, either angle C or angle A, measure and any one side, then you can find the remaining two sides of the triangle. And this we are going to study in trigonometry, how we can use uh, trigonometric ratios, which we'll see later, how to find the remaining two sides. Okay, so this Pythagoras theorem also we are going to use it wherever we need, and this also we will use how to find the remaining two sides when you know the measure of one of the angle apart from this right angle and one of the side. Okay, so let's now see what do you mean by trigonometry. Now we will see what is trigonometry, from where it originated. So it is made up of Greek word tri means three, gon means side, and metron means measure. So tri, gon, metron. Tri means three, gon means side, metron means measure. So trigonometry is the study of relationship between the sides and angles of a triangle. Okay. So trigonometry is the study of the relationship between sides and angles of a triangle. And this trigonometry, earlier astronomers were using it to find out the distance of the stars and planets from the earth. They were using the concept of trigonometry and they were able to find the distance of the stars and planets from the earth. Now next is, why in trigonometry we use only triangles? Why not different shape? We have so many shapes around us, isn't it? We have pentagon, we have quadrilateral, we have hexagon, but why we use only triangles? Because any shape you can divide in triangles. So if this is a rectangle, if I join one of the diagonal, I can get two triangles. Here I am getting three triangles and here I am getting two triangles again when I am joining one of the diagonal in a trapezium. That's why if you know the concept of triangle, you can use it in any shape. Okay. Now we will study some ratios of the sides of a right triangle with respect to its acute angle. And these are known as the trigonometric ratios of the angle. Okay. So here I have taken angle A and angle B is a right angle triangle of a triangle ABC. So already you know in a right angle triangle, hypotenuse is the side which is opposite to the right angle. My right angle is here. The side which is opposite to it is hypotenuse, isn't it? Now if I take this angle A, the side which is opposite to angle A is BC and it is also known as perpendicular. Okay, we can also name it as perpendicular and denote it with small p. Next, the side which is adjacent to this angle means which is beside it. It can be AB, it can be AC. But AC already we have given name, right? AC is already it is written, it is a hypotenuse. So AB I have written as side adjacent to angle A and it is also known as base of the triangle. Okay, and it is denoted as small b. So some of the books they write opposite side, some of the books they write perpendicular, some of the book they write adjacent side or some of the books they write base. So it's the same thing. Now I am going to take another angle for the same triangle, isn't it? Now I have taken this angle C. So hypotenuse will remain same because this is a right angle. The side which is opposite to right angle is the hypotenuse. So AC is the hypotenuse. Now the side which is opposite to angle C is AB, isn't it? And the side which is beside it or adjacent side, you can see it is BC. Okay, the side which is beside it is BC. Now we are going to use these concepts to find the trigonometric ratios. So the ratio between the length of the pair of two sides of a right angle triangle is called the trigonometric ratio. Okay. So what is trigonometric ratio? It is the ratio between the length of the pair of two sides of a right angle triangle. And there are so many, there are 6 trigonometric ratios. Now we are going to do it one by one. But before that, these terminology you should be very much clear, which is hypotenuse, which is the opposite side of angle, which is the adjacent side of angle. Because if you change the angle, your opposite and adjacent side will also change. Here if you see, when I take an angle A, my opposite side was BC and adjacent side was AB, isn't it? But when I took angle C, my opposite side is AB and the adjacent side is BC. So it got changed from here, isn't it? So you have to be very clear and you should able to find which is the opposite side and the adjacent side in a right angle triangle. Then only you can find the trigonometric ratios easily. Now the three sides of a right angle triangle give 6 trigonometrical ratios and they are sine, cosine, tangent, cotangent, secant and cosecant. So as some of the names are big, so in short we use sine, cos, tan, cot, sec and cosec respectively. When we solve the question, we use this short form only. So let's see the each ratios one by one. So sine of angle A, the ratio is side opposite to angle A by hypotenuse. Now side opposite to angle A is BC by AC, isn't it? This is angle A, the side opposite is BC by hypotenuse. Now I have already told in some of the books they write opposite side as perpendicular, which is denoted by small p, and adjacent side as base, which is denoted as a small b, and hypotenuse they denote with small h. So according to that also, if we write, it will be P by H. Okay. Next is cosine of angle A. Cosine of angle A is side adjacent to angle A by hypotenuse. This is the ratio of cosine of angle A. And side adjacent is AB, hypotenuse is AC. So it is AB by AC, which I can write as B by H. Next, tangent of angle A is side opposite to angle A by side adjacent to angle A, which is BC by AB, and which we can further write as P by B. Okay, it can be written as P by B. Now next is cosecant. Now cosecant is the reciprocal of sine, isn't it? So cosecant is reciprocal of sine. So I have written 1 by sine of angle A. And when we do the reciprocal of this, it will become hypotenuse by side opposite to angle A, which is AC by BC. And it can be further written as H by P. Okay. Next is secant. Secant is the reciprocal of cosine. Okay, so it will be hypotenuse by side opposite to angle A, which can be further written as H by B. Same way, cotangent is the reciprocal of tangent. So it will be side adjacent to angle A by side opposite to angle A, which will be written as B by P, base by perpendicular. Okay. So here we can see that the ratio of cosec, sec and cot are respectively the reciprocal of the ratios of sine, cos and tan. Isn't it? That's what I have written here. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So these ratios are very important. Okay, you are going to use it, and while solving the exercise questions, we are going to use these trigonometric ratios only. So please uh, go through all these ratios very carefully. Now see here, tan A is BC by AB. Why BC by AB? Just now we have seen the trigonometric ratios. Tan is what? It is side opposite to angle A by side adjacent to angle A, and side opposite to angle A is what? BC, and side adjacent to angle A is AB. So I have written here like this. Now here I am going to find out the relation between tan, sine and cos. That's why I have written here again tan A is BC by AB. Now I am going to divide hypotenuse, which is AC, in both numerator and denominator. So what it will become? So it will be BC by AC, okay, by AB by AC. What I did, I divided AC on both numerator and denominator. And we know that, right? If you divide or multiply in numerator and denominator, it remains same, isn't it? Now BC by AC. BC by AC is what? It is sine A. If you remember the trigonometric ratios, sine A is side opposite to angle A, which is BC, by hypotenuse, which is AC. So BC by AC I can write as sine A. And AB by AC is cos A. Cos A ratio is adjacent side by hypotenuse, and adjacent side of cos A is AB, and hypotenuse is AC. So it is cos A. So the relation of tan A is equal to sin A by cos A. Now same way, if you know tan A is sin A by cos A, we already know that cot is reciprocal of tan. So cot A will become the reciprocal of this, which is cos A by sin A. So this relation also we are going to use it in many places. So you have to remember this also. Okay, no need to remember means you should know the process how we are getting all these relations. Now this is a very important theorem. If the angle remains same, the values of the trigonometric ratios of an angle do not vary with the length of the sides of the triangle. Okay. So it says that if the angle remains same, here you can see there are two triangles APM and ACB. Okay. There are two right angle triangle, and you can see the angle A is common in both the triangles. So in such a case, the values of trigonometric ratios of an angle do not vary with the length of the sides of the triangle. though the length of the side of both the triangles are different. We can see I have drawn both the triangles separately also. So here is AMP, here is ABC. Both are having the same common angle. And what it says, if angle remains same, the values of trigonometric ratios of an angle do not vary with the length of the side of the triangle. Now let's understand this in detail. So if you take both the triangle PAM and CAB, you can see here that ABC and AMP, both the angles are right angle. It means it is 90 degree. And you can see angle A is common in both. Both triangle is having the same angle. You can see from the figure over here also, isn't it? And we have already studied that these two triangles will be similar using AA similarity. Why? Because this similarity tells that if two angles of one triangle are respectively equal to two angles of another triangle, then both the triangles will be similar. And when the triangle will be similar, their corresponding sides will be proportional. Now, what is the corresponding side? Let's see. So, if you take AM in the first triangle, the corresponding side is AB. Both are base with respect to this angle A. Now, AP and AC are the corresponding hypotenuse. That's why it is AP by AC. And then MP by BC are the perpendicular with respect to this angle A. Isn't it? So these corresponding sides will be in proportional. Now I am going to show that the values of trigonometric ratios will be same for both. I am taking these corresponding sides ratios one by one in pairs. Okay, so first I am going to take AP by AC equal to MP by BC. I can write, isn't it? Because all the corresponding sides are in proportional. Now what I am going to do, I am going to exchange these position BC and AP. I am going to exchange it. So it will be now BC by AC will be equal to MP by AP. And if you see the figure here, what is BC by AC? BC by AC with respect to angle A, if you see, this is the opposite side, isn't it? This is the opposite side. This is the adjacent side. And this is the hypotenuse, isn't it? Here also this is hypotenuse. This is opposite side. And this is your adjacent side. So if you recall the trigonometric ratios, here what is BC by AC? BC is opposite side by hypotenuse. Same way MP by AP, this is also opposite side by hypotenuse. And opposite side by hypotenuse, we know it is the trigonometric ratio. Which trigonometric ratios? It is sine of A. Okay, sine A. So here you can see, right, BC and AC, their measurement is different. MP and AP, the measurement is different. BC and MP measurement is different. AC and AP measurement is different. Still the trigonometric ratios, it is not changing, it is same. Now same way, if I take another pair AM by AB and AP by AC. Okay, so in this case, now I am going to exchange these position. Okay, so what you will get? AM by AP equal to AB by AC. And if you see the figure, AM is the adjacent side, isn't it? AP is the hypotenuse. And which trigonometric ratio is this? It is cos A. Okay. Now same way, if you take AM by AB and MP by BC, and you are going to exchange this. So what it will become? BC by AB, which is equal to MP by AM. And what are these? BC is opposite side, AB is adjacent side. Same way MP is opposite side and AM is adjacent side. And this is your tan A. Okay. So from here it is clear that if angle remains the same, the value of trigonometric ratios won't vary. It won't depend on the length of the sides of the triangle. That's what I have proved here, isn't it? In both the triangle, if you see the sine, cos and tan, these ratios are same. Now let's solve one question. I have taken this question from example 1 of the NCERT textbook. The question is, given tan A equal to 4 by 3, find the other trigonometric ratios of the angle A. Now other trigonometric ratios means what? You have to find sine, cos, cosec, sec, cot, all the trigonometric ratios you have to find. Here it is only given tan A is equal to 4 by 3. Now tan A, what is this trigonometric ratio? It says that tan A is opposite by adjacent. And if this is angle A, opposite side is this, isn't it? This is your adjacent side and this is your hypotenuse, isn't it? So if I write here, it will be BC by AB. And this ratio is given as 4 by 3. And if I assume the ratio as K, so you will get BC equal to 4K and AB equal to 3K. Okay, let the ratio be K. Okay, so if you take ratio as K, your BC is 4K and AB as 3K. So let's write here. Now we will use Pythagoras theorem and we will get the value of AC, isn't it? Because we need hypotenuse value also to find the other trigonometric ratios. So from here I can write AC square equal to AB square plus BC square. And AB square means 3K whole square plus 4K whole square. 3K whole square is 9K square plus 16K square, which will give you 25K square. So the value of AC will be 5K, isn't it? If you do square root of 25 is 5 and square root of K square is K. So the value of AC is 5K. Now let's find all the trigonometric ratios with respect to angle A. So sine A will be opposite by adjacent. Sorry, opposite by hypotenuse. So opposite is 4K, hypotenuse is 5K. So cancel out. So it will be 4 by 5. Now cos will be adjacent by hypotenuse. Your adjacent is 3K, hypotenuse is 5K, KK cancel, so it is 3 by 5. Tan value is already given. Now, next we will see sine, cos is done. Now, cosec. Cosec we know it is reciprocal of 1 by reciprocal of sine. So, it will be 1 by sine A, and if you do the reciprocal, you will get 5 by 4. Next, sec is the reciprocal of cos. So it will be 5 by 3, isn't it? And if you have to find the value of cot of A, it is reciprocal of tan of A. And this value was already given in the question. Tan A is 4 by 3, so reciprocal is 3 by 4. So now we have got all the values. So cosec is 5 by 4, sec of A is 5 by 3, cot A is 3 by 4. Sine A is 4 by 5, cos A is 3 by 5. So now I have found all the remaining trigonometric ratios, isn't it? So that's all for today's class. Now in the next class, I am going to solve the first exercise, which is exercise 8.1 of the chapter Trigonometry. Okay, so please go through all these introduction topic which I have done in today's class, and then only you can start doing the exercise questions. So that's all for today's class. If you like my video, please subscribe to my channel. Thank you.